Hi, my name is Sara Yacob, and I'm a chemical engineer. Today, I'd like to talk to you about a group of materials called catalysts. Everything from the shampoo you used this morning, to the chair you're sitting in right now, to the gasoline you put in your car, was manufactured at some point with the help of a catalyst. These materials have the potential to revolutionize the way that chemicals are made and produced every day. In fact, there are already hundreds of companies that devote themselves to making chemicals. Here are just a few you might recognize. Chances are pretty high that you come into contact with at least one chemical produced from these companies every day. And all of these companies use a catalyst to produce at least some of their products. So where do we begin when talking about a catalyst? How about with what a chemical reaction is? In a chemical reaction, we start with our raw materials or reactants, and we end with our products, like your shampoo. But in order to get from reactants to products, something needs to change. And in order for that change to occur, energy is required. In the drawing shown, A and B are your reactants, and C and D are the products. The energy required to get to the top of the hill is called the energy barrier. And once you get to the top of the hill, the chemicals look a little bit like both the reactants and the products. These are called intermediates. And here's where catalysts come into play. Catalysts work by lowering the energy barrier. In other words, they make that hill smaller. They can do this because catalysts form new intermediates, and the intermediates that are formed require less energy to be made. It's important to note that while a catalyst is added to the chemical reaction, it's not considered a reactant or a product. The idea is that a catalyst is used during the reaction, but it is not consumed. But what makes a catalyst good? That would be its ability to lower the energy barrier. How small can it make that hill? And while catalysts can be applied to many chemical reactions, my research focuses on applying it primarily to one. I'm working on designing a catalyst for the formation of propionic acid. Propionic acid is a chemical that is used widely today. It goes into preservatives, to pesticides, to pharmaceuticals, and even to plastics. If carbon monoxide and water are added to ethylene, you get propionic acid. I'm working on designing a catalyst that will form safe intermediates. We all benefit from safe intermediates. For example, the operators don't have to handle toxic chemicals, and it's easier to arrange transport of the chemicals on our roads and trains, and the engineers can design processes that are inherently safe. For these reasons, I'm working on designing a catalyst for propionic acid.